This function is a piecewise function. It gives us two different parts of it. When the breaking point is 0, if x is less than or equal to 0, it equals e to the ax. If x is greater than 0, it equals this function. It says f is differentiable, which just means that you're able to take the derivative at 0. Find the value of a plus b. So this is that one where, remember, if it's differentiable, it has to be continuous. So we're essentially forcing it to be differentiable and forcing it to be continuous by figuring out what a and b are. And then we'll add them together at the very end to figure out what the value is when you add them. So, first things first. If it is continuous at 0, that means that if I plug in 0 to the first equation and plug in 0 to the second equation, that they should be equal to each other, because continuous just means that the graph meets at the breaking point. So if I plug in 0 to the first one, I get e to the a times 0, and that should equal 2 times 0 plus a plus b. So if I simplify this, a times 0 is equal to 0, so e to the 0 power is just 1. And then on this side, 0 plus a is just a, so 2 times a would be 2a plus b. So I know that 1 equals 2a plus b. That doesn't help me to eliminate any variables. All that it helps me to do so far is to find one equation. So now we need to go to the differentiable part. So this one is the one that helped us to prove continuity. Continuous. There we go. So as long as we can figure out values for a and b that work in both equations, this part of it will make it continuous. Remember, in order to make it differentiable, we need to set the derivatives equal to each other at 0, which means we actually have to take the derivative. So if I find the derivative of f of x, so that's f prime of x, equals the derivative of e to the ax. We only know how to take the derivative of e to the x. So as soon as you throw an a in there, that kind of throws a wrench in our plan, and it becomes a composition of functions. So now we have a function inside of a function. So the inside function is ax, and the outside function is e to the inside function. So let me write it like this. And I'll put parentheses around this just so you guys can see what I'm talking about. So notice that I put little parentheses right here so you guys can see the inside function versus the outside. So my inside function is ax, and my outside function is e to the inside. So the derivative of the outside, remember the derivative of e to the x is itself. So the derivative of the outside is still e to the ax. And the derivative of the inside function, the derivative of ax is just a. So the derivative of this whole thing is a times e to the ax. I hope you guys are starting to notice patterns with these derivatives, because obviously it's going to take you a long time to write this out every single time. So I want you guys to start noticing patterns among them so that you can kind of jump to the end before you have to actually do any work. Alright, so that's the derivative of the first piece. The derivative of the second piece, I think it would help if we actually distributed this too. So if I distribute this 2, I get 2x plus 2a plus b. 2x plus 2a plus b. And a and b are actually just constants. So when I take the derivative of this, 2a is going to go away and b is going to go away because those are constants. So I'm really just looking at 2x. So the derivative of 2x is just 2. So when x is greater than 0, the derivative equals 2. So now that we have our derivative, in order to make it differentiable, again, in order to force it to be differentiable at 0, we're going to set these equal to each other and plug in 0 for x. So I know that a times e to the a times 0 equals 2. We're forcing them to be equal. So that's a times e to the 0 power is just 1. So that's a times 1, which is just a. So now we know that a must equal 2. So a equals 2, and that is going to help us up here, because now we can figure out what b equals. If we plug in 2 right here, we get 1 equals 2 times 2 plus b. So 1 equals 4 plus b, or in other words, b equals 1 minus 4, which is negative 3. And last but not least, it says to find the value of a plus b, so we're going to add them together. So when you do 2 plus negative 3, you get negative 1. So the answer is A.